Okay, so in this video we're going to be looking at the factor theorem. Now before we start, I just want to remind you of what a factor is, because it just helps you understand the factor theorem a little bit better. So if we remember, the factors of a number are the numbers that divide exactly into that number. So if we were looking for the factors of 12, the factors would be 1, 2, 3, 4, 6, and 12. And just remember that 12 is a factor because 12 divides exactly into 12 one times, and 1 is a factor because 1 divides exactly into 12 times. Okay, so this is what the factor theorem says. It looks a bit funny, but it's just notation. So if we talk you through it, it should be fine. So if we have f of a equals 0, then x minus a is a factor of f of x. Now, what does this mean? This means if we substitute a value, a number, for x into a polynomial, where say our polynomial could be 3x cubed plus 2x squared plus 4x minus 2, and we substitute a value for x, so we let x equal 2, and we put it in that polynomial. If we get the answer of 0 out, then we can say that x minus RA, it's important to note the minus here, is a factor of f of x. So what does that mean? That means that x minus a divides exactly into f of x. This is a very helpful thing actually, because it helps us factorize cubics, which could be difficult. Okay, so here's an example. I want to show that x minus 3 is a factor of this thing here. So comparing it down here to our theorem, we notice that we got x minus a here, and we're going to compare it with our x minus 3. So what we're actually seeing is that a equals 3. Now do be careful, because this is x minus a, and here's x minus 3, so a is just 3. If we had x plus 3 here, we would have to substitute for x equals minus 3. So we take our x equals 3, and then every time we see x, we put 3. So we have 3 cubed minus 3 times x squared plus 2 times 3 minus 6. So we put that all in, work it out, and then we get 0. Now, if we get 0 there, so f of 3, because that's what we put in, equals 0, we can say that x minus 3 is a factor of our polynomial. And that's what we wanted to show. Now, just an extension of that, we can use fractions, and that's fine. So this time we have f of b over a, so that's just some sort of fraction, equals 0. Then we say that ax minus b is a factor of f of x. So what does this mean? If we substituted 2/3 into our polynomial and we got 0 out, we could then say that 3x minus 2 is a factor of our polynomial. Now just be careful with the a's and b's and make sure you get them the right way round. So in this case, the a goes in front of the x, and the b is the number you're minusing. Now you might also be asked to find a factor. Now you're just being asked at present here to find one factor, and if that was the case, you would substitute different values for your a until you found the value of a which meant f of a equals 0. So I would always start with 1 because, you know, it's easy. So I put 1 in here, so I get 1 cubed plus 6 times 1 squared plus 11 times 1 plus 6, and I can see that that's definitely not going to equal 0. And if you look, everything's plus, so now I'm going to try minus 1 to see if that helps me get the right answer. So now I put minus 1 cubed plus 6 times minus 1 squared plus 11 times minus 1 plus 6. I put it all in here, and that's much better because I get minus 1 here, minus 11 times minus 12, and then plus 6 and plus 6, which is 12. So I get f of minus 1 equals 0. So my a is minus 1, and putting a is minus 1 here, I get x plus 1 is a factor of my polynomial. If neither of those worked, I would go on to 2's and minus 2's, and hopefully you wouldn't have to do it, but you could go to 3 and minus 3 till you found what you needed. Okay, I hope that was helpful.